Okay, test 5. Well, we've kind of been looking at some different topics, different concepts, but we end up doing the same thing with these concepts. And first thing we looked at was starting with acceleration, and then from acceleration and from knowing a few things about velocity and or position, we were able to answer some questions about the situation. Acceleration, to find the velocity, and simply integrate the acceleration. And don't forget the plus c. A lot of times we'll have information enough to find that value of c. And then to find the position, sometimes we'll use s of t or p of t or whatever letter you want to throw in there. It doesn't really matter. That's the integral of the velocity. And then again with the plus c, we can find, a lot of times we know the initial position. When t is 0, the position is 0, or the position, if we're talking about vertical motion, if a ball is thrown from the top of a building 120 feet tall, then initial position would be 120 feet. So the idea there, acceleration, velocity, position, integrate to get one of the functions from the other, and find the constants. Then we also introduced the idea of solving a differential equation. Fancy words there, but you're doing exactly that with acceleration, going to position, so forth. So any of these types of problems will be possibilities for the test. Of course, differential equations, we'll have an entire semester of that after Calc 3, so those of you hanging on till then, we'll see lots and lots more ways of solving differential equations, but you're at least getting an idea of what those are. Now, we looked at the acceleration, velocity, and position in several different ways. We also then focused on vertical motion and how gravity affects something falling through the air. Now, in those problems, we do assume that there's no air resistance. Air resistance kind of messes up that model. But again, in differential equations, we kind of have a way to take care of air resistance. But air resistance is the difference between how a ball falls through the air and how a feather just kind of floats through the air. So it is real. We have to take that into account. But for our problems, for our purposes, we're assuming no air resistance. We can assume that it's in a vacuum. We flip the vacuum switch and suck out all the air, and then feather and ball fall at the same speed. So I've actually seen that at a science museum. They have a vacuum hooked up to a tube with a ball and a feather. Well, you flip the tube over and the ball falls, the feather just kind of floats down. Flip the switch, sucks all the air out of it, and the feather and the ball fall at the same speed. That's pretty cool. So.
Is there like friction, what you said?
Air resistance. Air has some resistance to it, and that's why different objects fall at different speeds. So.
Due to the weight, or?
More surface area. The feather is a lot bigger surface area and lighter. Weight has something to do with it, but weight and surface area compared to a ball.
Okay.
So, but we will assume that we're in a vacuum, we've sucked out all the air, and that's not going to affect these problems. So these are the first, that'd be the first 2 or 3 worksheets we looked at, dealing with acceleration, position, velocity, solving differential equations as well. Now, the rest of the unit, we talk more about finding definite integrals rather than integrating, finding the antiderivative with the plus c, and then calculating what c has to be based on the information. The definite integrals, we looked at several different examples there. The next one was the average value of a function. And to find the average value of a function, well, say f of x over some interval, we'll just generalize it here, from a to b, maybe it's from 0 to 3 or from 5 to 25. Okay, the average value is calculated 1 over b minus a, and then times the integral, definite integral from a to b of that function. So I'll make sure and remember that formula. Not a difficult calculation, but remember 1 over b minus a. Yeah, question?
Would it be the amount on the top over b minus a?
You could do that as well. You could say the integral, that'll be the numerator, and then over b minus a. Whichever way you want to. Huh?
It's still the same thing?
Yep.
Oh, yeah.
So, whichever way you want to remember it and work with it. Okay. So that kind of got us back into working with the definite integral, and then the last several worksheets we were working with area of a bounded region, area between two curves, and then as we moved on, the area of figure out what area is bounded by 3, 4, 5 different equations. And again, area is going to be the top minus the bottom would represent the height, and then your thickness theoretically would be your delta x, or the dx part when you go to the integral. But on those, finding area, the trickiest part here is a lot of the algebra. The calculus is easy once you get the algebra part figured out. A lot of it is, what are the boundaries? Okay, we're integrating from where to where, and if it's just two curves, maybe it's a parabola, two parabolas like this. Well, what are these points? And then the top minus the bottom, if you want to draw a little representative sample, rectangle, slice, whatever you want to call it there, to get what we're integrating. It'd be this function minus this function. And remember, the minus the quantity, not just minus the first term, but minus the entire quantity. So in these types of problems, again, it's more lots and lots of work with the algebra, figuring out where the two curves intersect, or where the region, maybe it's some lines as well, and maybe it's something like that where you've got to really watch how the description of the problem is written. Something like this where maybe there's 2 lines and a parabola. There's a lot of different regions that this bounds, but in these types of problems it was bounded below by the parabola and above by the lines. Well, the region that we're describing here would be this one, bounded below by the parabola and above by the lines. And this one is even more work on the algebra part, and integrating. Well, first of all, we'd have to kind of think 2 separate integrals, go from here to here, where this one's the top and this one's the bottom, top minus the bottom, and then go from here over to here for the second piece. And the top this time would be the other line, bottom still would be the parabola. So we saw lots and lots of different setups for that. The area between 2 curves, area of a bounded region. Some of them we were, in most of these, we set them up y equals some function of x. But in some of the problems, we had x equal some function of y. And that way, maybe it was this, and then try to think of some.
And then y is equals 6 minus x.
Something like that. Well, with that, let's see. Let's go make it work out a little bit nicer here. That we would have our x equals y squared is a parabola. Yeah, that's supposed to be a parabola. Hopefully you guys draw better than I do. But and then the 4y equals 5 minus 2x, that's going to be a line, let's see, something like this. We're not going to graph it extremely accurately, but now in this case, it's going to be easier to go from the right minus the left. Set it up kind of with a horizontal representation, and instead of top minus the bottom, we'd go right minus the left. Yeah.
So with the 4y equals 5 minus 2x, you would set it up to solve for x?
Correct. Solve this for x to get what y would be. X equals something in terms of y. And let's see, we'll add 2x to both sides and subtract 4y and then divide by 2. X is going to be 5 halves minus 2y. And so we would integrate from, well,
You gotta set them both equal.
yeah, we'll have to find our integral limits, but the integrand would be the right, which would be the line, minus the left, which would be the parabola. And like I said, the most amount of work is the algebra. Now we need to find the y values in this case to get your limits. Goes from this y value up to this y value. So a little tricky when we kind of flip it around and do it in terms of y, but same idea. We're so ingrained with y equals a function of x, though, it's kind of hard to flip our minds around, and try not to flip too many times to flip out. But some of you are pretty close to that anyway. But okay. On the test, There's only 12 problems. As you've seen, the problems take a little bit longer, all that algebra that we do. So to allow you to get done tomorrow, I did limit it to just 12 problems, which means each problem is worth more now than just 5 points,
Oh my gosh.
or 5%. Yeah, out of 60 points, each problem will be worth 5 points out of 60, which turns into,
It's like roughly 18.
yeah, about 8% per problem rather than 5%. But it'll be, I mean, you'll have plenty of steps there to earn some points. So hopefully all of you will get the right answers. So it'll only take me about 10 minutes to grade all of them, but maybe not. Okay, yeah, this is probably one of the most involved. We've got 3 different pieces for our boundary. And to get an idea of what we're talking about here, let's go ahead and graph it. Now, x equals y squared, that's that parabola on its side, but I'm going to graph it a little more accurately than I did earlier. Let's go ahead and graph the y equals 6 minus x first, and then we'll fill in with the parabola. I'm going to go unit marks of 2 each. Kind of already ran out of room if I go just one, but so here would be the 6. Y equals 6 minus x. Let's go 2, 4, 6. So go slope of -1, we go down 1 and over 1, or we could go down 2 and over 2 with the markings we have. Let's do that. So down 2 and over 2. Or when x is 2, y would be 4. And let's see, as we continue going down, we would have an x-intercept of 6, 0 as well. And try to draw a straight line here. That's not too bad for me. You're not supposed to agree with that. Okay, now let's kind of fill in, show what this is going to look like now. X equals y squared. Well, 0, 0 will be on it. 1, 1 probably is not a good point to show very much accuracy here. Let's go out, let's say if x is 4, actually we probably should be choosing y and then find x, but in this case it's probably pretty easy. If x is 4, y is going to be what?
6.
Other way.
2.
Okay, y would be 2. We could just start out, if y is 2, what's x? 2 squared would be, so right there is going to be 1 point, which actually turns out to be a point on the line as well. If we continue the slope from this point here, go down 2 and over 2, we'll put it at that point as well. So sometimes in graphing, we luck out and find one of the points of intersection, more so by accident, but we'll have to find the other point of intersection as well, which usually would take some algebra. So let's see, we have our parabola. Now, before we go any farther, if this was just the area between these two curves, then we'd be looking at this area. But is that the region that we are talking about? No, we still need an area bounded by these two equations, but also the y-axis. The y-axis is this right here. What region are we dealing with then? Okay. This area right here. The y-axis, this line, and then the parabola. So to kind of pull that out to the side and show that really is the region we're looking at. Okay, so we we really don't need to find that one because that corner is not in the region that we're dealing with. We need to find that one, which didn't we already do that by accident? We said what? It's 4, 2, and then of course this one is 0, 0, and this one was 0, 6. Now, in this case, do we want to look at it in horizontal or vertical terms? Okay. If we go vertical terms, we have the top would be what?
6 minus x.
Okay, y equals 6 minus x. And the bottom would be what?
Y squared.
Okay. X equals y squared. Now here's a problem. We've got the line in y being in terms of x, but the parabola x being in terms of y. So we have to do what to which one?
Are we looking at vertical, right?
Okay, we need y equals, so the bottom we'd have to change to y equals the square root of x. Now technically y would equal positive and negative square root of x, but go back to the entire picture, y equals the square root of x would be this part, negative square root of x would be the bottom part. We don't need the negative part, we just need the positive. So keep that in mind as well. Sometimes you may need the bottom part instead. Okay. Now, before we set up the integral, what would happen if we did a horizontal slice on this?
You do double root,
Okay,
right?
right, because horizontally, we'd have to split it into two parts. This would be the right part on the top piece, but then the parabola would be the right part on the bottom piece. So we'd have to set it up in two integrals, go from 0 to, what was it, 0 to 2 in terms of y,
Bless you.
and then from 2 to 6 in terms of y. So sometimes it's helpful to go horizontal, but in this case, it's best to go the vertical because we only have to set up one integral. And let's see, I think we can fit that in here as long as, I know you guys can integrate this, but setting it up is the hard part. So in terms of x, what's our integral limits?
Oh, from 0 to 4?
Okay, we go from 0 to 4, again from here to here, which in terms of x would be our 4, and then top is the line minus the bottom, which in this case we have to change to our square root. So there is the integral of the area bounded by these curves, lines. Okay. Okay. And then from there, if you miss that, it's be careful. Watch those little dashed lines and all that. Okay? Questions on that? Again, recognizing the region that's being described, sometimes that's the hardest part, because some of these, there may be 3 or 4 bounded regions, but we want the specific one being described.
Wait, when I do